Alright. Alright. So yeah, we hope it's working. Last week we created a machine through various states that we will need for our pseudo computer, our virtual computer. Those are off, running, paused, resumed, and they will be things that machine is completely off. Running means it's executing code that we've written. Stopped the execution and we can't resume it anymore. We can restart. But it lets us kind of see where registers and memories at the current location, or the current. We can pause execution and then view our registers and stuff, and then doing all this stuff we can resume it and continue execution from where we stopped, and then make sure everything's clean on our actual machine as to not leave files and memory and all that kind of so yeah, our state machine kind of right now goes using a lot of pointers. Have our jump table here, which has our different functions that we use in our states. Now, what the input we get is, and that's what we did last week. And there is a video up on. It wasn't the best, but it is there. And then hopefully this time it'll be better. And if it's load, because I'm recording at this time. But this week, but the goal is to reading files, and, which will be our actual, and then from there parsing that, and how hopefully getting it to execute simple instruction set commands. So we will get started. Excuse me. So we'll start off and we'll class or call file. Everything should be, and we will create file reader H as well. So these are going to be where we actually read in the files that we want to parse. With we'll start with a static. We gotta get first. We'll do an H and then include stdio.h. The standard IO library inside our source file, because we don't need it in code files unless we're doing input. We don't need that permanently, so we shouldn't need it. And there's other things we're including std_lib standard library for stuff like malware places. So we can always use asserts instead, which are much better for debugging anyways. A static file input file. So this is going to be where we read. This is the one where we're going to read our file, because we typically want to keep the same file up, and it's just nice to have it static. We know it's not our. Let's make it a void for now. That opens up. So open file, and we'll take in a character string, just path, and here's where we will open the file. File equals fopen, and then name, path, and then read. write to it, just read, and then parse file. Need to take in anything inside the parse file. It can just be so we can check to make sure that parse file is opening a real file and that we've actually called open file. So we'll go to and we'll say if, but we'll just exit for now, and we can standard library. We can even print. We can print error message cannot open, or file was not open. There. Now we have. So now we're checking to see if the input file is null, and then from there we can print out if it was opened or not. If it wasn't opened, and then I guess exits. It needs library for that. Yeah, so now we just call exit and then just exit the program. Just error code -1. Nothing. Error code isn't too important. We just need to know that we exit because the file wasn't opened. And then from there, we can now start parsing the. So we'll create our. We'll make our file reader H. Alright, so now that we have, we can now put in our two functions we created. Open file parse, take any arguments, and now we should be able to start by, now we can find out, now we can start writing the code to actually read our file. What we want to do is we're going to want to read in a line, return that line. So we'll make this a pointer, and then set this one as well. So we want to read in a line of code, return that, and then that line is then going to be parsed. So we'll get the, we'll have the state machine break it up in sections. So for example, label if there's a label, the command, and the arguments if there's any arguments. So turn that line, and then it built-in file keep track of which line it's on, so we don't need to keep track of that. So that's there, but we will. So we'll start by calling read. Yeah, it's the one. Yeah, so destination. Okay, so we'll create a. Yeah, we'll go here just because that way we can always check first. Now we're not making an error. So we'll create. We'll call. So we'll make a constant value. 155 characters. That should be enough. I mean, we're creating our own instruction set, so we can always make sure that that's fine. So and then we'll read to line, size once, then file is input, and after that, and then we'll just return line. So here we just said we create 255 characters, and then we'll have to keep track of when we actually create a set that our label length defined to be, such and such a length, and then we'll have to make sure none of our arguments end up being longer than that. Let's just set it to 10. It's a safe length, and have extra space than not enough. And I mean, you can set this to any length. Powers of 2. Computers tend to things, and I know it's been drilled into my head that powers of 2 are always better, so we'll use powers of 2. And this here put into the header, reading it from a different file. But if we do, then we can always move it, and it'll still work. So that's essentially our file reading. Pretty simple. We should be able to it. So what we'll do is a state are here. So idle. This is the one we want to use. So get the command. Now get command is just all it does hard-coded to switch command. It's hard-coded to switch states. What we're going to do is we're going to basically remove all the code we wrote last time, and so we have create a command, and we allocate memory for it, and then what we're going to do, we're going to power on. So power on is where we're going to open. What we can do is we can do this. We can hard code a path, or we can get the user to enter the path. What I'm gonna do is I'm just gonna right into prompt user for path, and then so we'll start with by we'll print out first. So print. I always use file print. One of the university always emphasize print instead of and it lets you which file, if it's standard in, standard out, anything like that. But also I haven't researched this fully, but I think it prints out sooner than printf does because of the way buffers work. It out. I don't have stdio, so we do need it in more than one place. But well, actually, we don't. Actually, just call open file. And we're going to change this. Open file doesn't take arguments. What we'll do is we will path equals, and we'll create a function that, or get file location. So what we're doing instead of prompting the user in here for we have to include, we'll include really quickly include file. Okay, so what we're doing here is instead of prompting the user in our state machine for the file location, open file function that gets the file location from the user instead. this way was done in one function, and our state machine is just changing, not changing for input stuff. It's just doing the one thing it's meant to do. So we'll print out std out. We'll print enter path file. Then another constant, max, set it to 1024, and that's going to be the maximum length. So path max, and then we'll read f in read std. No, it's path and side, and then std. So this will read the path and check that everything is standard error path. So that's just going to let us check to make sure that the path is right. So now let's run it. And oh, we got errors. Let's see. That's right. Visual Studio use their secure functions. Nice guy. Quickly figure out visual disables. That's not it. There we go. This is the one I want. Okay, so here we go. So we go to seven. All right, and then oh, that's not. That's the one I want. And then we'll go C, C++, preprocessor, and then we will add one, secure, no warnings. Okay, so this is, it's kind of hard to read because the text is in the output box, but it's saying that it's giving warnings. Instead of using fopen because it's unsafe, you should use fopen_s, which is a function. Microsoft to be a more opening a file, but if you use those and if you use their security, try to go and all this code on SX or Unix, Linux-based derivative, it won't work. Definitions. So I like to just turn warnings aren't popping. Okay, use these ones. But now go to and look into what this error is. So file reader 31. Oh, I think it's another one of these where I have to move it to the top. Yeah. Yeah, that's another thing with Visual. I guess Visual Studio has a lot of these little things where you have to certain order in certain ways, and I'm not sure if I'm the biggest fan of that. Test path. Alright, so let's see. Okay. Let's try again here. Oh, let's go on. Do I actually have to enter in all these characters? No, that can't be. Let's try 10. Let's make a nice short cap. Let's see what's going on here. So that is 8 characters, 2 characters. Okay, so it has to reach the continue. Yeah, F open. Yeah, printing all that garbage. Oops. So that is right. Yeah, so what's happening is it has to read in the maximum. So if we set it to 1024, f read's gonna go until it hits 1024. Another way to do it would be to flip these. And I think if we flip these, I don't know if that makes a difference. So let's see. I think it does the same thing. Yeah. I know. I use certain ones have read lines and some don't. Let's just see here. I always forget the best way to do this. Line. I think it's a thing though. That's the problem. I forget how I always read. I always read input a certain way, and I haven't done input in a long time. So files. We'll just look at that really quick. This is a problem with doing different kinds of projects. So I'm just going to go to and grab an existing file here. And then, now I got to find, let's see. Oh yeah, doesn't help at all. Projects. Part about when you don't stop a project halfway through. That just reads a PNG file. There's one way we could do it, which would be once at a time. But that isn't ideal. Because, well, I mean, you'd have to get the new line character, which yeah. so many. That's what it is. It's fgetS that I use to read input. It's been a while since I've used the function here, but S is just get string from file. It grabs a string we pass, and it will. Yeah, it's much nicer way to do it. And there's also, if you want to, you can use getS. That just reads character. The next getS is you can always do set the path or the file you read from, which means you while you're entering the path location in, or if you want to, we can set it up and enter code directly into the command prompt window, and kind of like you do with the Python, editing and drawing, programming right inside your thing and doing it live. And so we can interactive like that, and have a set file we read from just by and setting the path to what we want it to have. So the max count will be path max, and the file is std in. Get the path. What's going on? Equals. Yes. So what's happening is it's just trying to open a exist. Because it's returning because it doesn't return anything, char path is being null, and it's trying to open null, and it's breaking because it can't handle. So what we'll do is we'll return path, and then we'll comment this out for now because that's just going to keep erroring. Oh, I didn't stop it. Alright, so start again. So test path to file. And now I get another error. Let's check this out. Interesting. Oh yes, because we're returning. Everything is returning empty. Okay. So so what we do is we're allocating memory, and what's inside that memory we don't know. So garbage value, and that it can't find a thing for that garbage value. So again, we could just we'd be best. Can we? No. Okay. So we had to finish setting everything up to run seamlessly to actually do this. So what we want to do now is we want to check the path is a new line character. If it is, for this is that if we punch in, if it asks for the path, if it asks for the file, and we just hit enter, means we want to go into an interactive file, reading input right the command line, processing it that way. It's not equal to an actual file. So what we'll do is we will if So the first character, new line. And equal new line, then we're in interactive. So interactive or else. We can put this there. So we want to use interact. So we should return. We can return an int. So mode equals 1. So we should actually here as well. So we'll do some more define interactive mode to be 1 and define file mode 0. So we'll actually rearrange these so that way they're in inventing order. And then just to make sure everything lines up. So now we should create the it just creates these and sets them to what they should be, and then we'll return. Let's actually make this so static int mode. We'll make it for s. What's a static? We know it's going to be consistent. Entering into file mode, and that mode is just something that isn't typical to do because it's a nice option to have, and it's really simple to put in. So now we should change that. Okay, so if we're in file mode, and then from there, we can tackle parsing. So now parsing is going to change because our input file isn't necessarily going to be null if it's wrong. Exit if it's null, and the mode file mode. The file was not open. Okay, now f s equals interact or file mode. Actually, from there we can actually s and then case file and break and then interactive. Now what we can do is, so here we just exit now. Instead of exiting if the file, we exit null and we're in file mode. At A, we want to actually read from a file, and B, we don't have a file to read from. In the other case, if we had left the way we had before, being in interactive mode, create a file. What it would do instead is it just reads from the input, so it doesn't create a file, making this every single time we run interactive mode. Something we want to do. So now is we can make so here's where we want to so here for file mode we fget at, because it's going to be the same, because all we got to do now is read a line. So here we want to line max. File mode is going from the file. Active mode we want to read from standard input. So same thing, line max, but this time cd in and input file. And then like before, we return the line. Now it's mode and file. So now I return that. We can doesn't return set it up top and then everything else is handled. We open the file. This is all right. Void char. Yeah. Okay. So then this is a local function. We don't just need it from in here, so I can. Okay. Open file is undefined. Oh, we forgot the at the end. All right. Open file. Perfect. Now, in here we'll call so create our line max, and max then I guess has to move now. So we'll move it to file reader H. This way, state machine will have a line of the same length that the file reader is giving out. So line and line equal. So oh yes, this is a pointer. Char. Actually, line max. Yeah. Okay. So instead of using size of, we just use line max because a character is 1 byte. Size of line max is the exact same as line. It's each character is 1 byte, and malloc allocates 1 byte at a time. Max is 1024. Of line max, it's 1024. If we do line max times size of char, where'd the highlighting go? My highlighting's all gone now, which bothers. There, it's back. Okay. So line equals parse file. Let us. Now we need to decompose the line, the command. Okay. Notepad. So our instructions, the way they work is you typically have a label, optional, and then an argument, and then after the optional argument. So every command is going to have at least one. Commands will have these are branching instructions, moving to a different location in the line. These are typically, if you have 2, it's typically a load or a store operation, and then if you have 3, it's typically stuff like math and anything kind of comparing stuff. But the thing we'll have to do is we'll have to find out if the first character is a character or if it's a space, a white space, a new line, whatever. So here we are going to need to write another function, and we'll create a new file for it just to be simple. So we'll call this one cmd parser.c. and then we'll create a file, and we'll call it cmd parser.h, and we'll move this one over here, and do our typical header file creation. And then here we are going to create, we're going to want to take in command, and we're going to want to parse. So we'll start off by include so include the right file, and we'll create a function, and what we do is accept a line. So we'll check we'll do let's see. Okay, so what we're going to do is we're going to include where is command? Command is defined. Is defined here. Okay. .h. So include state machine. And the reason we're doing this is because now we can create a function. Let's create a void function for now. Parse command. So somebody just asked coding a VM. Kind of. It's kind of a virtual machine of a custom set of a custom instruction. So just to recap, I said set yet this time. If you look at stuff like the LC3 on the Little Computer 3, a MIPS simulator. LC3 is a custom one. MIPS is a legitimate instruction set, and what they do is they run kind of virtual computers that execute an instruction set or a assembly. Is an assembly language that you can write code and kind of a but what I'm more focusing on is working more towards the LC3, so more of an assembly language. But from there, I'm hoping to, from there I want to expand better, and then we'll see what we can do from there. Obviously, you won't be able to take stuff like the Linux executed on here, but I would like to make it to the point where you can, make a simple little operating system that executes and does what it does. But right now, we're just working on reading source code that themselves. So we're creating an assembly language, creating a program that assembly language, and execute it. And then from there, stuff like multi-threading is going to come in, and then from there we're going to hopefully all stuff that's going to come in, but I think it could be a lot of fun to do. I'll have to answer some questions there. Right now, we've just created a state machine, both the different states of the system, and then we wrote something to read from a file, a source code file. Excuse me. What we're doing is we're commands that come in. So what we're going to do is we're going to take in a character that it's parsing, and in a command pointer, and that's command that we want to build. So in git command, we create a command that as an argument to parse command. Excuse me. Inside parse command, and all git is it just says, oh hey, I want a command, and it gets it. Creates it, it reads stuff, and then it passes it along, and everything gets done. So now we can put this. So now let's set this up so that get command can call it and then all that stuff up. So parse command line command. Ah yes, we have to move this to there. Now that command is here, it knows the machine, and then this includes this. So this includes the command parser header, which lets it know command what command, and then it's also this also knows because it's here. So basically, it gives both files the ability to know what command is. So then you go to state machine, and now state machine is going to go to parse command, and it's going to do as the argument, and then C. And it needs to parser. Okay. So now it knows, and now when we modify this command, it the command variable in here as well, and return the one we've. So now we can start parsing. So the first thing we want to do is check for a label, and then check for command, and then get arguments. So what we want is label. The first thing we're going to do is excuse me. We're going to I'm thinking a couple steps ahead here, but that's stuff that I want to tackle later on. So a label is used in jumping. Want to go to a different line of code. Is we're going to go to and that label. Now, current situation, if our label is below our current line, we have to find a way to skip down. And with that, the problem is we need to skip. One way to do this, and I think this is the way it does it, is you first scan a file and you store in a table all of your labels. And what you do is you just jump to the way we're going to do it so far now until it's a major issue is we're just going to read a line, check if the label is the label we want, and if not, we're just going to read the next. So that's one way of doing it. There's many ways of doing it. That's what we're going to do. So the first thing we're going to do is, and the way to do that is we can impose strict a very set rules on our language, and what we can do is we can say, because we're writing it ourselves, if the first character in line does not equal then we have a label. So read-label. This means that if the very first line we've read is that means that the very first part of it's a label, which we said is optional. So if we want to have a label there, we can. I mean, label on every single line in an instruction set doesn't do anything. It's used for jumping and stuff like that, which makes it necessary. So we could also include spaces. So if you want to like 4 times or 8 times, whatever, you could do that. But I'm the kind of guy that likes to use tabs. So if it's fantastic, we'll just use. Excuse me. We're gonna change this actually to. Let's actually add. We don't use command anywhere else, so we're actually gonna go to the state machine.h, and we're going to. So our command has a single character that we use for and because using the character rate, we use characters because we can then store 0 to 255 inside these, which these are just usually. So let's just use a number from 0 or one of registers. So we can index 255 easily. This is a lot more than almost every single process you ever find comes with. And that's something we can change if we need to. I mean, we should actually, depending on how big character, depending how big operation is, how many operations we have, we could actually probably do one sign char. Use bit manipulation, and then more space. It's kind of unnecessary since we're a machine like this where we don't need to worry about that. But if we wanted to run this on with a lot less added systems or stuff like that, where they have a lot less storage available, we could drop it down. But what we're going to do is we're going to add char pointer, and it's going to be label. And so we can just store the label inside the command, and it'll very easily. Now we'll go to the next one. So if line 0 does not equal tab, get the label, and then what's next would be to get the command, and then get the arguments based on how many arguments the command. So we just see where our commands are. Yeah, so right now we're reusing our command. We're reusing command to store states as well. So not only are we treating subtract, multiply as, we're also treating stuff like stop the machine, resume the machine as commands as well. Will come in. Those will come in from. So if there's like a, you can click it and it'll send the stop command, as opposed to coming from the file typically. Label. If it's not, or if it is a tab, then we want to get and then we'll get the arguments once we know what kind of command. So this one we can, so we'll unsigned char. So we'll create variables. These return the that we need. CMD. And then we'll go C label C command. Oh. Okay. It's going to return the label, and then we'll put it into the command variable here, and then get command is going to get the command we want to execute, and it'll store the command variable as an operation, and then we want to get arguments. And this actually has to return oh, come on. If I can type, we have another one that returns our get command. Okay, so now the way get label is going to work is it's going to take from the string the first it has to be one, so a line that we want to parse, and then what we'll do is we'll create a static int x. We'll set it to 0, and then and then what we'll do is we'll do this the hard-coded way, which I prefer because we don't have we separate our with and with so tokenizing the same line on with multiple things will give us some problems. So if we're trying the line on spaces, split the label from the rest of it, and then we can then write a whole nother token with tokenizing with commas for the second. But what I'm going to do is I'm just going to get a character from the I need stdio again. What I'm going to do is I'm just going to read a character from the, and I think I hit a button. I think I hit a different than I wanted to. Oh no, we're fine. Okay. So instead of using split and token like a tip, what I'm going to do is I'm going to read character by character, put it into a label variable, and then return that. And it gives me a little bit more control, which I love to have in programming. So, but here the static index, this index the entire line, and it's so that we make sure when we increment, it'll be incremented here as well. That way we always are starting from the same location when we want to keep going, and we're not starting at 0, label in, and then starting using the label as the op command, or as the operation of the command. What we'll do is we'll start with a character, a char, and what we'll do is we'll define a maximum label length. So label max get 5. So we have 10. So we have 1024 6. We have 4 bits available for our line. Our entire line is 1024. So what we want to do is we want to make label 1/4 because we have 5 and we can't 4 into 5. This command, depending on most instruction sets, will have this as 3 or 4 characters long. So that takes up, and then 6, that gives us 60, meaning 1024 minus 260 is going to be for the 3 arguments. That can be split evenly or not, but we can always go look, but it's nice to have non-arbitrary stuff like labels, and 256 characters for a label should be more than sufficient, but you never know people labels. So do is now we will loop, so while index does not equal a space or line index, a tab, or line or index is label max. So what this does is it lets us control, yeah, I'll leave these here for now. I can, but it fits nicer on this with the larger text. This, but so what it does is a space, or if the next character is a space, if it's a tab, or if it is less than label max. So if it's a space, we're done reading the label in. Tab, which it should be, instead of a space, we're done reading the. Actually, let's just take this out. I don't want to use spaces. And then I guess we can put. So if the character is a, or if the character we're going to read is a tab, we're done reading the label. We can just stop. If the index is equal to, or for some reason max, we're done. That's it. That's last. Let's set this. So we're gonna set this to label -1 and put a small character at the label. Everything handle nicer, stuff like printing and all that kind of stuff. So if index is 54, or if index is equal to 255 or greater, or if we get a tab, it just stops us from reading the line in, or stops us from reading the line because and if it's anything else, what we're gonna do is this. So for this, and then we'll do label max. So allocate enough memory for this label, and then we will equal line index. We will just copy the character and then increment, and if we want to get fancy, we could do like index plus plus, or index equals line index plus plus, and put that all in one. But this is nice and simple, makes everything easy to read. And then just loop, and we break. And then from there, return, set label index to be and then return label. So this sets the last character, and then we'll do index plus plus and return label. So what this does is this sets the last character in label. If we read in test is our label, read in test, and then set the fifth character, or the character after the last T character, signifying, and then everything's all good. Actually, we don't need. So here. So if we read in test, this will read in test, and then the last increment will put us at one passed. I'm going to draw this out to be a little bit less confusing, easier to understand if it's drawn. Oh, come on, there we go. Okay. Alright, so it's on the wrong monitor. The way this works, we have our all the way from 0 to 255. And if our label is test, we're going to read in these, put them in the label, and break out of our while loop. And then we're going to set, because index is going to equal 5, if our line is here, index will be the fifth one, which will be a tab, and it'll still be pointing at the fifth one as well, since we're using index to iterate through that as well. We'll set the null character here, and then time when we read again, even though we've accessed this one, we'll point here to the tab and we can read the tab and then start reading the. So hopefully that's not too confusing. My explanations sometimes are more confusing than the actual reading. So next would be read the label. That's all it does, and then the label's fine. I'm actually going to put this right into there, and then I'll put this in there as well, just so that it's being put in there as it's done. Again, we're going to want to put in the line. But, so now we want to read in the command. So here, now, so this one is a little bit different, because we are using unsigned char values for our command is going to be a string of chars. We have to convert from 3 or 4 characters into unsigned chars. The way we're going to do that is we're going to use something, we're going to use an array. No, we can't use that either. Be interesting. because we want to use chart to make it on this, to make it simpler. We could change these from single. Oh wait, no, because we use this to index. Okay, so yeah, we use these. Use the unsigned index into our jump table here. It needs to be unsigned. So to handle that, we can handle a lot easier. And what we're gonna do is find a way to convert strings into scalars. And I don't know if we can use a switch case for that. I don't know if that's something we can do. If we can use switch case for strings. Yeah, no, you have to use an if-else ladder. Yeah, or hashing. But that's a lot of work for something so simple. What we'll do is let's just first of all just so very similar. Okay, so char command equals char malloc. Actually, this one we can set no, this 4. We'll this though where we command so let's give them a 4 characters for what we're going to do is we want to by incrementing, and this will past the tab that we have. Skip tab. What we'll do is we'll line x equal a comma, or let's actually make this 5, and then yeah, there we go, and then is less. Here, what we have to do use 0 our index to the command length. So what we'll do is we will set a static int, and we'll create length 0, and then what we'll do is we'll label length equals index. What we'll do is it'll set label length to 5, and 5 be text, or the 5th character be the tab. So it read T, increment to 1, read E, increment to E, increment to 3, read T, increment to, and then we'll go breakout. So we increment here, index, and then the T, and it says 4, which is, So T0, E1, S2, T3, and then it goes K. 3. Okay, 4 is going to be the tab, and so we set the length to 4, which means from T to tab. So if we go back to our file here, let's make this font big. Font. Okay, so here we have st command with the tab 1, 3. That should be a tab as well. We'll change the number. Okay, so let's say that's our in. So it'll read in these 4 characters, and then it will increment 1, and what is label length? Label length is 5. Okay. So label index plus 1. Index, right? So it'll be 4. So this is label length. Because we read in little marker there. That's what we've read in. And that's set to label length. Now, what's next is to go to command, and we want this to be zeroed. A D equals 1 equals 2. And the way is because this is 0, 1, 2, 2, 3, and then 5, 6, 7, 8, 9, 10, 12. So we read in, so what we want to do is we want to say, okay, 0 and index equal 5, and that will set, or actually we should call this command offset. That'll probably be a bit more accurate, or a little more helpful than label length. So here we have label equal to 5, and now what we can do is we command, so my offset is less than command length right here. So index is command offset, and it's actually CMD offset, less than command, and command length is 5, so minus 1, and does is x from 5. That's the first one. 5 minus 5. So while 5 is less than 4 character, so it's 0 is less than 4, and it lets us index whatever will be the correct line. It'll also let us use it to index our internal array for command. And use CMD offset equals line index, and now it will store in 0 what's in 5. It'll store in 1 what's in 6. It'll store in 7 or in 2 what's in 7. It's just shift everything over while still using The other one is, as the line. So now we have, we'll do static int arg offset, static int arg set, and static int arg3 offset. So that gives us all the single character we're going to need. And again, what we'll do here is we'll do cmd minus cmd offset equals bracket. So that just sets the command to a or whatever you want to call it. We'll increment it, and then we'll set arg1 offset to index. And then we'll return a string, not a character. So now command. Now is oh, I forgot that. Okay, so now what we gotta do is we have to get the operations. So char unsigned char I keep deleting characters when I type. Okay, so now let's say op equals get op and return op. So now you've got to make a function, and we'll call it unsigned char get op char command. So it's going to take in the command we just created. What it's going to do is it's going to be a giant if-else statement that checks the command to be equal to the other one, and then or command is equal to, and then from there that's the unsigned char. Kind of a long, but that's the best way to have it. So an unsigned char op, and then if compare string dot and what compare easily cmd to add op, and we'll include cmd in add. So we have 156 available to us because we're using an unsigned char, which gives us 0 to 255. So 0, we have our commands for machine, and then what we'll do is we'll just start from an arbitrary number. I'll start from because that's just a number. Actually, I'll start from 16. That gives us 16 operations that can be used for handling machine. Yeah, we'll start at 32. I'd rather have a gap, a large gap in between our machine and our language commands, or our machine operations and our language operations, just so that way if we end up, let's say I end up with a 17 machine, I'd have to go to and now either increment all of the operations, or and put the new machine operation at the end. So let's just get less chance It still could, but it's less. And then, if necessary, we can always move operations between without much hassle. So subtract will be 33. Not a logical not will be 6. Logical or will be 36. Logical and 38. And we'll do that right now. So op will be add. If stir compare cmd sub op equals sub. Our language will be case sensitive, and that change. And that's one nice thing with writing your own language. You can specify. So it's case sensitive. If to all lowercase right here. You know what? Let's just do it. Let's just make it to lowercase. I'm just going to look up how to do that again. Okay. Okay, so the way to do this So I'm just what we're gonna do is just convert this all ways to do this int I in a nice way. It's nice to do. So I d len 1, and this lets us loop and it lets us ignore the null character at the end of the string. Need to convert that to lowercase. So what we'll do is we'll say cmd I equals 2 lower cmd I. To lower and in which okay c dot h. Okay, so now we have to lower. So now what we're doing is just converting. We are converting our character string from case mixed whatever to all lowercase, and lets us it lets us ignore case sensitivity. So if you want to write your code all in uppercase, I want to write it all in lowercase, it will always convert here. Div not so this will get fun when we have a lot of commands we're able to go through, but that's just sometimes, and then alright, so there we go. That's we have operations we have, And then what we'll do is we'll return op. I don't know if this shouldn't change the command in here. But, we'll just receive the command as a, and then when we convert it to lowercase here, it'll be in lowercase here, which shouldn't make, and it kind of saves us a little bit of space using the same variable. Have the operation. Now we have to get the argument. So these ones all use arguments. I'm trying to think, is it 2 arguments? Okay, so why is not? Trying to remember how it works. x86 assemblies. There we go. That's not what I wanted, I don't think. So here, this is the LC3 instruction set, and so this is let's find you. So add and branch jump return SR. These are ones. So their not is A, not B, or rather, it is a 2 instruction or 2 argument. So we'll move this one here, and we'll set this to 36, and we'll set this to 64. And we'll call these operation. So add will be A store in C. Subtract will be A minus B store in C, A times B store in C, A divided by B store in C, A or B stored in C, A and B stored in C, and then A XOR B stored in C, and then A stored in B. So we'll just add XOR here. XOR equals XOR. Okay, so actually, what? So we can call these 0, 0, 2, 0, 3, and then we'll call this one to be 30, 31, 33, 34, 35, 36. So now use, so we'll just make another one here, 1 argument. This one, branch, show what's going to happen. Branch, and we'll 10. And now we'll just put it just so it's all in there. Stir compare br op equals branch. So now what we're doing is we're using the number to specify the number of arguments we need. So branch is one argument. Is 2 needs 3 arguments. So what we're going to do is so there's a number of ways. Would be to left number of characters to what we can do is we can just mod 10. No, that I just did this in a and we used differently. Divide by 10. Divide by 10 is 3. That should work. If we do 30, if we argument divided by 10, because it's an integer, it won't give us. No, it needs to be. No, that won't work either. We'll do this the easy way. So we'll switch op and case 10 case 11. Too much. We'll do it if statements. Greater than or equal to 10, and op is less than or equal to 19. Get one argument, and that'll be a. So we need more of these now. Op 1, 2, or actually arg1, arg2, and arg3. And will be arg1 equals oh no. Yeah. So it actually has, so if command is greater than or equal less than or equal to 19, it's 10, 11, 12, 13, 14, 15, 16, 17, or 19. We'll get the one argument and pass in line. If it is greater than or equal to 20 and equal to 29, arg this is actually wrong. A char 3 args and C# code. So we can do args equals args. Oh, it's got to be alright, so we have to actually I got it unsigned. So inside of our array, and then we'll return them, get 2 arguments, and then finally else if cmd is greater than or equal to, and it's less than 39, args will equal 3 arguments. And then once we have the arguments, we'll put them arg1 equals args 0. And then that has to go all of these. Do some code repetition, but it's only a few lines, so you probably could do this without the duplication, but it's easy enough to just do it, so we'll just do it. Okay, so now that we have the arguments being started from the line. So what we'll do return unsigned char array get recom out, and then we'll do above it 2 arguments, right? Get 3 arguments are line. So the reason we have them in order, wrong one, is because we can call get, so we can have unsigned char args equals, actually let's save memory and we'll pass args, and as always reuse the same thing. So unsigned char args, unsigned char args, and one last time unsigned char args. So now is from get 3 we can call get 2 arguments line args, and here we can call 1 argument args. So here get 3 arguments we'll call 2 arguments, and get 2 arguments we'll call get 1 argument. So this one will read the first argument, and then it'll return I'll set these all to void since we don't need to return. So it'll come down here and it'll go, okay, we need 1 argument. Okay, argument returns a single. Okay, so let's say we need calls a second, and it says, okay, get the first one here, and then I'll get the second one myself. And then it goes, okay, get 3 arguments, and this guy's, I don't feel like doing a whole lot of work. I'll get the first 2. Well, I'm not doing the work. I'll get the first one. Adds on the second one. Comes here and he adds on the third one. So let's not have to read 3 times in this. And each function basically reads 1 argument, but it's a matter of which argument it reads. So always it's the same as it was before. Unsigned char op char arg, and we'll need an argument length which we'll set to 4. Arg. And the reason we're doing is because then we can do $R2 and have that null character at the end like always. So do arg, and then like we did before, while index does not equal, and instead of it being a comma or a tab or space, it's going to be comma index minus arg1 offset is less than arg len minus 1. And then what we'll do is we'll do arg index minus arg equals index. And then index plus, and then so this actually can all be cleaned up into one function. And that I'll once I've got it all done here. So it's index minus arg1 equals plus arg2 equals index, and then args 0, since we're in the first, equals get you'll call arg, yes, and then we'll and then return. So what get arg is void or unsigned show arg unsigned args. This is going to convert again whatever it needs to be converted into. So we'll do the same thing we did, and we will first this actually a repass. We're passing a oh, this has to be unsigned. Actually, this can be just a character, because all we're reading, not reading unsigned characters, we're reading regular characters. So this can be characters, so it's a string, and then I, and sign char, and have these as arg. Now we need to have arg. This can go in its own header file. So add arg index. So standard arg h and we'll have define red 1 will be one. Reg 2 to 1. 3 to 2. Reg 4 3. Actually, we'll make this 0. 1 2 3. Reg 4 4. Now we'll just include, so let's do those for now. We'll have more later. Arg, and we'll actually call it registers. Name too many times. Rename X. Okay, and we'll call this okay. So now it's all changed up there. So now do if 4 int equals 0 and arg len my I I do lower I, and then if stir compare args to R1. Actually, this we don't want to convert because this should be mandatory lowercase. Arg register. We'll call. I think that this is going to be something. Yeah, we'll deal with this next time. Register or number or value. So here we're going to check to see if it's a register use or if it's a like 10, 47. But that's something that we'll tackle next. But we'll do this time with this, and then we'll go sign char op need op. We'll go char arg len while we can actually just copy code here. And again, this is why we're going to move all of code into its own space, and we're gonna its own function that we can reuse, so we're not repeating all this. But that's something that next time as well. Have a little bit more time, or a little bit less. Going on. So here, exact same thing as above. Argument 1 offset. We use argument 2 offset, and then we set the get args, and then one more time. All this and char arg len and paste all this, and then instead of using arg2 we use arg3, and we're missing our thing there, and then arg3 and then arg3. Don't need to make another offset because that's the last offset. That can be a, and that's 2, and then that's everything. Now, depending on which one it calls, it'll go to and create all 3 arguments, and then it'll grab them, and then from there we'll send them into here to the registers. Parse command, everything else is internal. File reader, state machine, file, parse command, and then returns. So now we've gone from having a simple little statement that from different states we find or interactively and then now we should be able to pull this build, make sure it works. Failed. Okay. Arg must return. Okay, so that we actually return something. But we not only lines, we actually also parse them, and we would have off what the command is. So again, I will go to and I will call this code a lot nicer, and I'll make sure it's nice and descriptive and everything. And then last time I'll throw it up on my GitHub. The link is in the video. You'll be able to find it there. And then whenever YouTube, however you process this will be on my channel, so you can rewatch at your own convenience. But if anybody has any questions, please let me know. Questions, and this is a confusing project, but it is fun and I am enjoying it. So hopefully you're enjoying watching it. And again, next week, so it's p.m. Central Standard Time. It's 900 or 7 UTC. And next time we'll keep going with this, and we'll get the commands parsing and get them actually have an add to number, and after that create our registers to registers. After that, we'll work into actually simulate virtual memory or real memory, as in RAM, like your computer has. So that'll be next time. But if anybody has any, type them into chat, let me know. I'm always happy to answer questions. This will be commented and up tonight, so it'll be a little bit later on. I will, everything's saved, so I will push it right now. So we'll save. What? Commit failed. Well, let's look at why it failed. Let's push. Add dash. I guess. It's because it's got to close this. Okay, so let's close this. And now let's try committing. There we go. Okay, sync it up. The code's up, and then later tonight I'll go to and I'll comment it all up, and then commit it all, so that it's all, that way it's all easy to follow everybody else. But so that, and yeah, I'll be back next week Sunday. That'll be January the 25th. 3 p.m. Central Standard Time and 7 p.m. UTC. So if you guys want to tune in again, that'd be the but for now, so long. Hopefully you guys enjoyed it, and hopefully